So today we're starting our new year, and we're going to start with some solving of simple equations to kind of get us started. So here's where I want you to follow along, copy down the things that I'm writing down. Don't assume anything that should be there. And then as we go through together, then we'll have the note sheet filled in. Then we'll take questions in class if there are any. So an equation is a statement that two expressions are equal. A solution of an equation is the value that makes the equation true. So expressions make up the equation, and the solution is the value that makes those expressions or the full equation true. So inverse operations are two operations that undo each other. So basically, they are the opposites of each other. So we know addition and subtraction are the opposites. If I add 5 to something, if I subtract 5 from something, I get right back to where I started from. The same is true with multiplication and division. So they are opposites of each other, so they would be inverse operations. We're going to learn about some others throughout the year, but those are the ones we know for now. So solving equations with addition or subtraction. So some of these we can do in our heads, but we want to understand how to do these without trying to do things in our heads and showing the steps. So here's how we will work on this. So if I look at my equation, x minus 3 equals negative 5. What we want to do is move everything away from the x, or isolate the x, get it all by itself. So what I'm going to do here is I am going to add 3, because subtracting 3 and adding 3 would cancel each other out. So if I was to add 3 to both sides, this little kind of imaginary line creates the wall between my two expressions. What I'm going to get is negative 3 and a plus 3. That's going to cancel it out, leaving me with just x. And on the opposite side, negative 5 plus 3 is a negative 2. Now again, how do I know that's right? The one great thing about equations is I can plug in this solution to see if I get the right answer. So how I check that is I'm going to take the x value in my equation and replace it with what I think is the answer. And then all I have to do is finish putting together my regular order of operations to see if it's true. Negative 2 minus 3, does that equal negative 5? And it does. So I know I have the right answer here. X equals negative 2 is the solution. Okay, so by doing a check, I'm just plugging it in. I can walk away from this problem knowing I have absolutely the right answer. So next one. So now I see 0.9 equals y plus 2.8. So to get y all by itself, again, we're thinking about this little imaginary wall. We're going to kind of get y all by itself. I'm going to move the 2.8 to the other side by subtraction. If it says that I would add it, to move it, I do the opposite. And I have to make sure I do it to both sides. So 0.9 minus 2.8 is going to give me negative 1.9. And on the other side, 2.8 plus minus 2.8 is 0, leaving me y equals negative 1.9. Now again, to do a quick check, to show my check here, I would just write what I have so far. Now when I get to the y, I'm not going to write y, I'm going to plug in what is the value of the y. And I don't know why I'm my cursor is not working well today. I'm going to see if we can get this thing a little neater. And then just to verify, I get 0.9 equals 0.9. So that works. So my answer is y equals negative 1.9. And again, we know some of this is a little bit easier for some of us than others. We know some of this we can do in our heads, and that's great to do some of this in our heads. But we also want to be able to show the steps so that we understand how this works. Okay? Now we get to multiplication and division. So on this first one, we know that this symbol, or hopefully we know that this symbol right here, is a fraction bar, which is also another word for division. We talk about numerator, which is the n, divided by the denominator. So if we think of it that way, what we need to do is undo division. Well, you undo division by the opposite, which means to multiply. So what I'm going to do is, and I'm going to write it this way, I'm using parentheses, I'm multiplying both sides by negative 5. And I'm going to do both sides by negative 5, and hopefully we can all see the reason, because negative 5 times a negative 5 would give me positive 1. And that's what I want, right? So negative 5 times the other negative 5 gives me a positive 1n. On the other side, negative 3 times negative 5, you know the negative times a negative is a positive, so I believe the answer is 15. Now again, to show a check here, now I'm going to take out the n and plug in the 15 that we think is the answer, or the solution, and then we can go through and say, well, does this work if that number is in place of n? Well, negative 15 fifths is negative 3, which is the same thing as negative 3 on the other side. It definitely checks. So n equals 15 would be the correct answer. Next one. So the next one, again, we're looking at the symbol 1.3x. Remembering when I don't see a symbol and I see a number next to a variable, that means to multiply. So this time, to undo multiplication, we're going to do division. And notice that I'm doing the little fraction bar. We just saw in the previous example that that means to divide. So if I do 1.3x divided by 1.3, I get 1x. And that's what we're looking for. 1x is the same thing as x. 5.2 divided by 1.3 is 4. So again, to show my check, I take the 1.3, I'm taking the x out and replacing it with the 4 that we just think is the answer, and see if, when 4 goes in, these two expressions equal each other, and I will get 5.2 equals 5.2, so that works. My answer is x equals 4. So on the next one, so we're looking at a little bit of a two-step equation, which you should have seen a little bit last year, and hopefully we can kind of talk through it a little bit. So what happens on the two-step equation is I am still going in opposite order of my operations, but I have to think about the order that I do these in. So for this first example, 3x plus 2, I see two operations there. 3 times x plus 2. Two different operations. So how do I know which one to do first? Well, what we do in this situation, when I have more than one operation than I am undoing, is I actually go in the reverse order of my order of operations. So normally we would do the multiplication first. So in the reverse order, we would take care of the addition first. So in this case, what I'm going to do is subtract 2 from both sides to take care of the plus 2. Okay? Now, once I do that, I bring down what I get. The 2 and the negative 2 cancel, leaving me 3x. 14 minus 2 is 12. Now I relook at it. I still have to get x all by itself. So 3 times x, I'm going to do what we just did in the previous one. The opposite of times, or multiplication, is division. So now I can divide the 3's to make 1x. 12 divided by 3 is another 4. And that's how I would get to the answer of that. Now again, to verify, I would say 3 times 4, so I'm replacing the x. Does that give me the 14? Well, now I would do my regular order of operations, because when I have all numbers and operations, regular order of operations. So this time I will do my multiplication first to get 12 plus 2. That does equal 14. So I have the correct answer of x equals 4. So the next one, same idea. I see two operations, division and subtraction. Regular order of operations, you would do division first. So in opposite operations, I'm going to take care of the subtraction first. So the very first thing I would do is add 6 to both sides. I'm going to get 14 on the right and a divided by 3 on the left. Now to undo that division, I would do the multiplication. So I'm just doing the parentheses to symbolize that we're multiplying there. And I'm going to say, okay, if I multiply the 3's would cancel out, and a would come out as 42. And again, I'm not going to show a check this time because we've done it several times, but if I showed the check here, you would have 42 divided by 3, which becomes 14. And then when I subtract 6 from 14, I do get 8, so a equals 42. Next, we want to start looking at just some problem solving, and we're going to try to do lots of problem solving this year just to kind of help make sure we can take our math knowledge and apply it to problems that we're trying to solve things. So this is just kind of giving you a little bit of a rundown here of reading through a word problem, understand what's being asked for, understanding what given information you have, and then what is it that you don't know that you need to figure out. Then you want to figure out a plan. You want to figure out, well, what do I need to do to get to these answers that I just talked about? Figure out the plan you are and then solve it. Figure out if your plan comes up with an answer, and then look back to make sure your answer makes sense. It doesn't do any good to come up with a number that if you look back into the problem, you say, for example, this thing can be done in 3 seconds, but you know with common sense that it would take 15 days at least. Think about, does your answer make sense? Because maybe you found some number that might still need to be used to help find the actual final answer. So here's an example that we're going to look at. The Olympics, Usain Bolt won the 200-meter dash with this time of 19.32 seconds. We're going to understand the problem, make a plan. We can understand it by knowing the winning time and distance. You're asked to find the average speed to the nearest hundredths. That's always an important thing. The winning distance and time is important to notice. And we're going to figure out our distance equals rate times time. So whether you have done this one or not, or remember this is our formula of the distance formula. D stands for distance, rate, that's really our speed, and T stands for our time. So D equals RT. So here's how we would solve this, or one of the ways you could always solve this. So again, we're going to use that formula. Distance equals rate times time. Well, if I look at the distance, we know that we are running a 200-meter dash. So there's your distance. That doesn't change. The distance of the race is the distance of the race. We don't know the rate. So what we are trying to find is the average speed, and rate is speed. So we don't know that. That's the thing that we're going to leave for now because we don't know what that is. However, we do have a time, and the time is the 19.32. Okay, so this is the equation that we're going to use, make it our plan. Now we're just going to follow it out. So like we did above, this is saying R times 19.32. So to undo that, we need to divide by 19.32 on both sides, which then means we're going to have the R all by itself on the right-hand side. And on the left-hand side, we're going to get something that is approximately 10.35. Now remember, they were asking us to round to the nearest hundredths. So we do need to make sure that we are rounding to the nearest hundredths, which means we sometimes have to go out to the thousandths, would be one more place to see if it was a 5 or higher. So the answer here is the speed. R is our speed. He was running 10.35 meters per second. And it's always important when you're doing any kind of a word problem to make sure that you have your label to show that you know exactly what we're talking about in this context. And then lastly, we have this solving strategies. Lots of different ways you can solve problems, right? I'm never going to tell you there's only one way to do something. The important thing is that we follow through with whatever plan we have and that we show our work so that anyone can follow our work. But there's more than one way to solve a strategy and figure out how to get to answers. So our last example. We want to understand this situation. We have the temperature in Spearfish, South Dakota. It fell from 54 degrees Fahrenheit to -4 in a very short amount of time. Basically, we just want to know, well, how many degrees did it fall? So obviously, to understand the problem, we just need to know the temperature before and after and find the degrees, how far it fell. So that's just kind of understanding what we just looked at and read. So here's the plan that I'm going to look at. And this doesn't have to be the only way to do this. I'm going to say my plan is it was 54 and it fell some degrees, which I don't know, and it ended up at -4. Okay? So that's kind of my plan. And then to follow this out, my plan is going to be to get to what x is. Now notice what I said was x. So here's one of the things that we sometimes can run into trouble with. We don't see a positive or plus sign here, but we all know that if I don't write that plus 54, we just write 54, we know that that's a positive. So to move the 54, I need to do the opposite of plus 54, which is minus 54. And this example is a good one to make sure that you don't fall into that trap, okay? Minus x is affecting the x, not the 54. So you don't want to say, oh, add 54. You're taking away 54 and putting it over on the right. So what that's going to leave me is -x on the left-hand side. And we got to keep that negative there because we're bringing everything down. Also, now on the right-hand side, I would have -58. Now, we don't want -x, we want positive x. So the way I undo that -1 times x is I would really just do a quick divide by -1. That's going to now make the two negatives a positive. And on the other side, those two negatives make a positive. And 58 divided by 1 is just 58. So that would tell me that the temp went down (58 degrees. And we need to make sure that we have that 58 degrees. Okay? So that's just another way of kind of getting some examples of how to set up some of these word problems. Hopefully that makes some sense. A lot of this is some things that you've already done. It's a little bit of a kind of a review and refresher, the one-step equations and also some two-step equations. If you have any kind of questions, please make sure you write them down and be sure to ask me about them when I see you in class.